hello, or as I've heard, there are like a lot of Spanish and German people here. Hola, hallo. Make sure that most of you feel included now. Yeah, thanks all for coming. Welcome to my talk. It's how are you all doing? End of the conference. Still a bit of energy left. 2 more talks, and then you're all done. I guess you have been flooded with lots of information, or with lots of wine and information. And yeah, I'll try to make this pretty easy to digest for you, so not you don't have to, and make it yeah, easy as I said. So let's start. I just noticed the projector here makes the things very dark, so this dark man should actually be me. And yeah, my name is Matthias. I work for a company called Novatec. You probably have seen a few folks of Novatec running around. We have a branch in Spain, and we're originally from Germany, so that's why we have quite a few people here, which makes me very happy. That what most people probably don't know, that besides of my talk at Novatec, I'm also teaching at 2 universities in the area of Stuttgart. That's in the Hochschule für Technik and the Esslingen University. And what I'm teaching there is distributed systems. And this is also basically the title of the talk. So I didn't want to explicitly call it microservices. It could be microservices, but distributed systems does not have necessarily to be in microservices. And if you hear it, it might sound like a bit of a dusty and old kind of subject to teach. So what I'm basically trying to do is to teach distributed systems with modern technologies to make that somewhat more exciting and closer to the real world for my students. So this is what it's going to be about today. This is what I would consider as modern technologies. And the idea for today is basically to have a bit of a look into each one of those. So in the middle, this should symbolize a typical distributed application landscape, and then we have the technologies of Spring Cloud, Kubernetes, service meshes, and eBPF. And I will try to do a bit of a walkthrough through those technologies and give you a bit of an initial impression what they can do in order to facilitate a good distributed systems behavior. So yeah, as this is a Spring conference, of course I'm going to start and put Spring Cloud into reference and then try to relate all the other things here. So there have been quite a few talks and topics, what I've seen around Spring Cloud and of course Kubernetes. This is pretty much everywhere. I don't think there has been much around service meshes and eBPF. So yeah, this is what I hopefully can add to the equation. Yeah, and it's like I only have 50 minutes, so don't expect a deep dive into all of those technologies. So I'm more like scratching a little on the surface, and it's more important for me basically to make sure everybody has a common understanding of what they do, what the differences are, when to pick what, which are probably good patterns, which might not work so well, and so on. All right, so I'm going to start with why. I always like to do that, and say basically why would do people distributed systems in the first place? Then how can that be done? What kind of ingredients do you need to have? And on the what, I'm looking at some of them. As I just said, Spring Cloud in both forms, like standalone and also with Spring Cloud Kubernetes. If the time allows, I do a bit of a live demo, and hopefully we'll come to a bit of a conclusion there. I'm doing this talk for the first time, so I'm not exactly sure how this will work out time-wise. I might have to speed up or slow down at some point, and we'll see how that goes. All right, so why do distributed systems or distributed architecture in the first place? In general, I hope this is kind of visible in the very far back. So here we have clients that basically try to access a system. And the question would be, why would I break down a system into multiple pieces in the first place? Am I not going to just like multiply my problem, or is there actually something good behind it? in the end, the important factor really is, no matter if it's like a single monolithic system or a distributed system, basically the way you want to do it is to improve the quality of your client. I mean, the client could be humans, but it could also be consumers, like other applications, trying to access that system. And now, of course, one obvious thing is to say, I want to do multiple tasks in parallel. Maybe I have different tasks that play into a certain combination and then deliver a common result to a client. Another one could be that I have some heterogeneous landscape in the first place. So that could be on an operating system level. That also could be on a framework and application level. So yeah, I have put down a few technologies there. But even if you don't want to do like a polyglot microservice with 25 different languages, it's still on a smaller scale. It could be that you are running Spring Boot or Java applications and then have them in different versions. So if you have like one big application server, this is also something which is not possible. So you might have things like Java 11 or Java 18. Please nobody tell Josh that I have Java 11. Say, just tell him what's Java 17. We only use the modern things, of course. Nobody has ever seen Java 8. And another thing is, of course, also to make a system more extensible and give it more room for growth. As it's already kind of in a distributed way, you can add easy a lot more pieces to it. Now, these are the things that play into that heterogeneous part. The other factor for distributed systems is more like under the umbrella of resilience. So people might do a distributed system to have one system and scale it to multiple instances. So if one if one instance goes down, the clients wouldn't notice. Another form of that would, of course, be to load balance between those systems and distribute the load in order to serve more clients on an increasing demand. Another factor would also be to block. If you have too many clients coming in and trying to access your environment, to make sure that nothing breaks internally, you could also say, well, I'm going to stop the traffic because otherwise my environment will not be healthy anymore. Maybe in the meantime, I will scale up, and then I can distribute to more systems. But in the end, it's about protecting the systems and still deliver a client experience that will not cause a further fallout or something like that. Of course, this can be done also in a more granular way to kind of throttle the traffic and say, instead of blocking it entirely, I might just rate limit and make sure my systems get that amount of load which they can actually cope with and still give me the flexibility to react on that traffic if the traffic changes. Yeah, security is, of course, something that should also be mentioned here. Basically, there could be a part of the system that does some authorization, authentication parts and make sure only those requests that are allowed can come in. And another thing which we see very often, of course, is that we roll out new versions of the software. And, of course, we don't really want the clients to notice that, or to have like a bad experience in case of a downtime and have to wait until the service is available again. So there are things like blue-green deployments where, say, you roll out a new version, and if it's good and tested well, you switch the traffic. And so the client just gets the updated version but never sees the outage. The other more advanced behavior here is called canary deployment, or also sometimes percentage routing, where you can say, I want to granularly control how that traffic is being split. Not like from old version to new version directly. Once this is ready, maybe I just want to route a certain percentage to the new version. This could either be like just by a number, but also by client properties. So we see that from Facebook, I think, very often when they roll out a new feature and only certain geographies get to start with it, and then when things get better, they replicate it to others. So we're not going to build Facebook, but you can still do those things on a smaller scale. Now, there are probably more But these are the ones that I'm going to start with and look into in the comparison later on. Now, if we want to do that, so this is like kind of the why part, and now it's like, what do we need? No matter which framework or whatever we take, we need some elements that kind of control the network, that can say, well, we can do the routing or traffic shaping and do all those things like either blocking traffic or sending the traffic to different endpoints or distribute it or throttle it. Another thing which is very important in such a distributed environment is like a service registry, like a telephone book, so to say, so that people, like the systems do not only need to talk to each other, but they also need to find each other. And so that services are able to register in the first place, and when somebody else comes and says, well, I want to talk to that system, then it can look up in the telephone book where it is and pick up the connection. The other thing is distributed configuration. So if we have a distributed landscape, we cannot make sure that we say, well, they all know the same thing at the same time. And we might be in the need for such a situation that we say we want to push out configuration to multiple clients, or they might be able to pull it in case they need some new information. So we need some distributed configuration instance. In addition to that, of course, for troubleshooting purposes, distributed logging and tracing and potentially observability, I forgot to mention that on that slide, basically to get a bit of better control of that distributed landscape. All right, so to make up a kind of a sample, we could say, yeah, we have kind of an edge component which routes and shapes the traffic. Then we have some internal services that talk with each other, some different databases, caches, messaging system, whatsoever. I didn't want to make that picture too complicated, but all of them should then be connected to the service registry, configuration, and troubleshooting / observability kind of environment. So, and then you can do those things like deploying different versions, balance that traffic, or deploy multiple versions of one instance and do some load balancing there, and hopefully apply all those things in a granular way whenever you need it and however the application logic of the application is. All right, so now that I've been talking about 20 slides, I'm finally going to mention something Springish. So I called this, and I told you, I'll make it an easy visual thing for you today, so I hope it was not too hard for anybody yet. So I labeled this Spring Cloud Classic because that's kind of the way it looked when I started getting in touch with it about 5 or 6 years ago. There are components on this page which are actually not, which are still around, but I don't think they're supported anymore. But we have like Zool in the beginning was like an API gateway. In the meantime, Spring Cloud Gateway is probably the better solution. Then we had Eureka as that telephone book config server. Hystrix as a method for resilience, which could do like circuit breaking and bulkheads and other like mechanisms to block traffic and make sure your application stays healthy. And we had Ribbon as like a client-sided load balancer that could query all the instances from Eureka and then distribute the traffic across them and feign as a declarative REST client. So these are the things that basically I got started with. The way they work in Spring, and as I said, I'm going to start with this one, is of course that will probably most of you know. You build this functionality into the various services. That basically makes it very often a combination of dependencies, maybe some annotations and references in the code, and additional external configuration properties. I mean, one thing I should probably say, what I see now, you in the back won't see it, it says Netflix here. So those initial services were very much influenced by Netflix, and then found their way into like the typical Spring Cloud ecosystem. All right, so this would be like how you would set up a Eureka service registry. On the other hand, you could also work with your clients to say, okay, now how do I talk to Eureka? So you had a dependency here in the code, you say enable discovery client. In the configuration, you provide your service name, and with that name, you're going to get registered at the service registry. In turn, you can invoke the service registry and ask it, yeah, where are all the other things that I want to talk to? And in the Spring Cloud Gateway, for example, you have also dependency, and then you can either define the routes or the behavior of that gateway via application properties or configuration properties in the code. So I'm not going to go through all of them. The point that I'm trying to make with this is just if you use such a framework-based approach, all the elements will be tied and bound to your application. And that will be a difference to the technologies I'm going to talk about later. The advantage of that, of course, is if you have all those functionalities bound to the individual instances, so they're running basically in the process of the application, it makes them very independent of the underlying runtime. So they could all run on one machine as different processes and communicate via localhost and just different ports. And in the same way, each of them could run on an own machine and then use the underlying network and communicate with IP addresses and port combination. Of course, nowadays, most of them would probably run in those things called containers. But from a perspective of the implementation, it basically totally doesn't matter. I mean, there might be some different configuration properties that you need to specify for one or the other underlying environment, but it doesn't make a change to the technology and the framework. So to sum this up, with Spring Cloud, you have the characteristic of that it's running as part of the application process, combination of dependency, code, and property. And of course, this is basically very important when it comes to observability. If you run within the process, you also have the metrics of this process. As I said, it's independent of the framework. You have different options how to implement. And, but in turn, it also means if you want to change something, you need to rebuild. So there's if it's like a dependency change or a code change, you need to rebuild. If it's only a configuration, it's not. But if you take one functionality in or out, that would require a restart. In the end, that enables you to say exactly where I want to place which kind of component, pick the right tool for the right job, and have it as lightweight as you can have it. So that's kind of the part for Spring Cloud. Now, everyone, including myself, is talking a lot about Kubernetes these days. And so this is the one we're going to look into next. So of course, this originated out of the things running stuff in a Docker environment. And as you can see, the big Docker limitation that there is that the Docker daemon basically just spans around one host. So it cannot orchestrate Docker containers across multiple nodes, at least not in the default way of settings. I mean, there are many technologies around it that might do that, but Kubernetes is probably the one that has the highest adoption rate. And the way things work in Kubernetes is not that those containers are running as containers just that. They are being wrapped into like another container, which is called a pod. Now, again, from the perspective of Spring Cloud, that wouldn't really matter. So you could still use the service registry, configuration, resilience mechanisms, load balancing, and so on. Now, the situation, however, is that Kubernetes brought along own technologies to kind of address the same problems. And Kubernetes was not really built with the idea of Spring or Spring Cloud in mind. It was more like built to run distributed applications no matter what kind of an application framework or infrastructure they are. So they have an own service registry. Well, basically they have a DNS and like an etcd store for the configuration components, but that's in the end where your service objects will be stored, and in the DNS you can query what is around. With config maps and secrets, you have configuration properties for external, and with observability, you have way too many options anyway, so I'm not going to go into that much. But you then have these components like deployment, replica set, and in particular the Kubernetes service that I'm going to have a look at next. So the replica set would take care of scaling your instances. The deployment can handle the situation or the requirement to work with two different versions. And the Kubernetes service acts basically in two different roles. So the Kubernetes service, that's basically a way how it would be implemented, has a name, and with that name, it's going to be registered in the internal service registry. And with this selector, it points to potentially one-to-many different endpoints that it's basically load balancing around. So if I have like this replica set of 3 services with that label, then the Kubernetes service would distribute the traffic across those. And so that means, what does that mean for Spring Cloud? Would I start to run a Eureka instance in Kubernetes next to that service? Is there a way how to integrate that with that nicely? There was a really cool talk this morning by Ryan Baxter. I don't know who saw that. He went into the details of exactly that topic. So if you want to know more about that, I would definitely recommend you, if you haven't been there, to watch this recording. Because as I said, I can only briefly go into. So as I said before, this is the Eureka behavior. And what would of course be important from a client perspective, that if you go from a Spring Cloud standalone into a Kubernetes world, that things would basically work in exactly the same way. And that's pretty much what Spring Cloud Kubernetes kind of achieves. So you have to change some dependencies to like Kubernetes-based ones, and potentially also change some configuration. But from a code perspective, it's the same thing. So you also like annotate with enable discovery client, and if you query something from the discovery client, it's not going to reach out to Eureka, but to the Kubernetes service registry. So it's you don't necessarily have any code changes, and can just use the same code in a different environment. The other one is config maps and secrets. So Kubernetes has this 2 different configuration objects. They're mostly kind of key value files or like simple configuration properties. In the secret stuff, things are being encoded. They're not encrypted, that's important to know. They're just encoded to make, like, they're not readable for a human eye. But it's not like a security mechanism that would encrypt your things. Anyway, if you have such a config map, and then you have a match between the name and your client config class, then you can also use this as a configuration object in Spring or Spring Boot in the same way as you would have done if you queried things from a config server. So also, this is kind of, gives you that config server / Eureka kind of feeling, even when you're inside of Kubernetes. So to sum things up, if you use that configuration, you can say, okay, Kubernetes provides the out-of-the-box functionality for scaling, load balancing, service registry, external configuration, and a few more things. What it doesn't provide, if we relate to the things before in Spring Cloud, are these things for resiliency patterns. So there is no, you cannot control the network traffic in Kubernetes on your own to say, well, I want to block traffic, I want to have some circuit breaker or bulkhead or whatever functionality. That's out of the scope for a base level in Kubernetes. So in that combination, Spring Cloud adopts with Kubernetes without any code changes. And as I said before, you have like Eureka-like behavior or config server-like behavior with things like with the Kubernetes registry or the config maps and secrets. All right, so how are we doing time-wise? That's good. Now, service mesh. Service mesh is basically a technology which has just been built on top of Kubernetes. So as we heard before, a base element in Kubernetes is this so-called pod. And this pod is basically a wrapper for a container instance. And important to know is that this is, of course, connected somehow to the Kubernetes network traffic. But you can also have multiple containers in one pod. You shouldn't necessarily place application containers of the same application or multiple distributed services into one pod, because then you don't have the possibility to scale and shield it in a different way. So the question is, for me in the beginning was, why does Kubernetes do that anyway? And one answer is that you can, of course, say, if this application sees everything what that application sees, you can make use of that. So that you can implement like agent-like behavior for one of the pods and the application-like behavior for the other pod. And that's basically the primary concept of a service mesh, where you say, instead of an additional app component, I'm putting that proxy component down. So this proxy component would see all the same network traffic that my application sees. And it can now act on that things. For example, either to route it somewhere else, or to throttle it, or to encrypt it, and all those things which Kubernetes does not provide out of the box. And then this starts to make sense if you have multiple of these. So basically, this proxy component is not something that you deploy once. It's going to get injected into every pod in that environment. And then you can basically collect and summarize all of that network data in your cluster and send it to one control instance. So people speak very often of a data plane and the control plane here. And then on the control plane, of course, you can take actions on what you see and do with that traffic. This, of course, means it will work very well also with different types of Spring and Spring Boot components. But of course, it worked well with everything else too, because it is not bound or tied to the application process. It's just injecting that proxy into the pod, but it doesn't have any idea what the application container next door does. So this, yeah, I don't know why would somebody would do that and take so many things, but technically it's of course possible. Now, the other advantage is, as you don't have to change your application to use it, you can very quickly just turn it on and off, because it's just like injecting something into a pod. It doesn't necessarily treat the runtime of the application. The pods will get restarted though, but in the same way as Kubernetes would always do that. But it doesn't require any modification on the application container. Then you can collect that and work with it. So what would that mean in our diagram example? So basically, the pod would kind of get extended, and then you would get this proxy component everywhere. You could have that on the side of the gateway, but especially important on every instance. So not on every deployment, but really on every instance. So if I have a scaled deployment, multiple instances, then this proxy component would be in there. And that's, of course, also one major disadvantage, because you pay the price for that everywhere. I mean, you can limit it down and say, I want to only use it in this kind of namespaces or not. You could potentially also not use it in some of the pods explicitly, but then I think you have a configuration overhead which doesn't make any sense. And yeah, so then all of those things in your cluster would then be connected to the control plane, and you have a lot of additional network traffic. So this is why people also call this service mesh at sometimes. And but in the end, yeah, this is the way how it works. So what can you do then what you couldn't do before? I mean, in the initial Spring example, we had like that routing component as like an entry level into our application landscape. Now, as we have those components on each of the things, we can also configure each of the connections. So I could say I will have a mutual TLS connection between those services in particular, and lock down the traffic for everyone else, and so on. This is not possible with Kubernetes out of the box. So you could say, yeah, if you have a source label, it's coming in from here, and I want to go there. So I only allow that connection. If anything else comes in, it's going to get blocked. And I can encrypt it on top as well. Of course, it's Kubernetes, so it's going to be all YAML. I mean, alternatively JSON, but I don't know if anybody prefers that, to write it from scratch. So this is what we're basically going to face. Now, the other thing what you can, of course, do as well is granularly split the traffic. So you basically have this endpoint, and this endpoint, and this endpoint. And then I can say, OK, this is what I want to apply to divide the traffic in the way that I want to. Of course, I can also completely block the traffic and throttle the traffic. Technically, this is a thing that the Spring Cloud Gateway can, of course, also do. But it's just like, you don't have it on every occasion. So the question, I mean, of course, it's getting pretty obvious what it can do. The question you would always need to ask yourself is, do I really need that? Of course, it's pretty fancy, but it also has kind of its downsides. So here you can say I have two different destinations. I can select a certain weight, so it's 75 and 25 this time, and then we would get this traffic balanced. So this is a list of things that you can do with traffic. It's not just like the routing and the security. You can also resilient things, not just circuit break or retries. You can also use it for like fault injection. Goes in the direction of resilience or chaos engineering, where you can inject failure and test things like that. You can do network policies and all those things. And if we look back to Spring Cloud Gateway, you would find most of the things there too. So if your application is structured like that one, it's most likely, yeah, you wouldn't be in need of starting with a service mesh. Except if you start putting multiple Spring Cloud gateways with many different configurations into your traffic flow, then it might be a point to say, well, maybe you should look for an alternative technology. All right. So this is, I have some screenshots, but I still hope I have some time to actually demo this in the end. So I'm going to jump over this really quickly. Now, this is the other thing, which is very important. There's not just one service mesh implementation. There are many. The most famous ones are Linkerd and Istio. The examples that you have seen or that I'm going to show are being based on Istio. And I don't know how to explain to you how that diagram works exactly. So it's the latency at 20 requests per second, and with different percentiles. The only thing which you should be aware of, there will be a significant overhead by using that service meshes. It's kind of natural because you add additional network hops. That's the one thing. On the latency side, also on like the memory consumption side, you have that proxies running everywhere. And if you have a lot of small components and a lot of scaled instances, it's not going to get any better with this. So the good thing, it's easy to try, but this is something you should check out if this is a price you really want to pay. All right. So summarizing the characteristics here, you can extend Kubernetes for those limitations that it has in handling the traffic. So yeah, Kubernetes is not really traffic aware. The only component is like the service that would load balance in that kind of direction. And here you have that concept of injecting a sidecar into each pod. But of course, also when it goes into the direction of observability, here you don't have any application level metrics because the proxy doesn't know about the application. It gets all the network things and whatever you can do it with them, but it's not like an agent built towards a certain application infrastructure. And yeah, that's why you have that configuration changes not at build time, but at runtime. Okay, so we're going to come to the final bit, which is called eBPF. So who in the room has heard of eBPF? A few. So this stands for Extended Berkeley Packet Filter, which kind of does not explain a lot more. And it doesn't sound like something related to what we're kind of doing here. So it's a low-level kind of Linux technology. And please don't ask me any deep dive questions on how that would go. I think the easiest way to explain it, or that's kind of what enlightened me, so to say, is eBPF is for Linux what JavaScript is for HTML. So you can kind of embed a sandbox code, or like run a code in a sandbox environment of the Linux kernel. And this has then no possibility to do any harm and or become in any way malicious. But it has the option to query things and get kernel events. And one of those kernel events are, of course, the networking events. So with everything that it can collect there, it can then send it to the user space where those information can be processed any further. Now, we're still very low on a Linux level, and you might want to think, how does this relate to Spring Cloud and what we do? Now, if you look at a Kubernetes node, you probably, if you ever had a look into this, I normally would not recommend it. In the end, what you need to know, this is the part that runs the containers, and in the end, Kubernetes will wrap all the API objects around it. But internal components in the node are, of course, the container daemon, then the kubelet and the kube proxy, and the operating system. And very often, this operating system happens to be a Linux operating system. So that means this is where you can apply this eBPF technology. And yeah, so if you look at the things now compared to what we did with service meshes before, here you have an amount of nodes, and then you have, like in this case, a kind of a daemon set, which is your which provides a pod as your eBPF edge component. You have some additional things that run on a lower level on the kernel, but you can see the difference from, like, I think a cardinality standpoint compared to service meshes. Here you have your proxy component once per node. In the other one, you have one per pod. And so technically, this is, of course, able to query and work out all the network traffic in the same way as the sidecars would do. And then send all this to a similar kind of control plane to take any actions. So this kind of would give the possibility to have like a sidecar-less service mesh, so to say. Now, yeah, this can be symbolized very kind of quickly. So instead of having all those proxy components in the instances there, you have all the proxy components on the node there below. And then they will only speak to the control plane. So that also means, of course, if you want to inject or take something out, you don't even need to modify the pod or restart the pod. You do that once on the nodes, and then you can start working on the things. And right now, this is very young. I mean, I don't think the BPF technology is so young, but exploiting eBPF for Kubernetes is fairly new. I think it has started about last year or become popular last year. And there are a couple of companies providing some stuff there. Cilium is one of them. And so, for example, you could now enforce also network policies or encrypt traffic between components or do any kind of more sophisticated routing behavior. So they also just started. And they have now started a beta program of what would people be interested when having a service mesh. And their current plan of action is kind of to work that down from a priority. So observability is also something that they have provided already. And now encryption is the next thing. And so this is more like a bit of a technology outlook than a realistic comparison to the things that we have seen before. Anyway, to summarize that, so you inject the proxy on the node instead of the pod. It's a Linux low-level functionality. It's still very young, but can use that one for a second. Yeah, good timing because I just wanted to start the demo. Hello, hello. Yeah, well, okay. I think people can hear me again. All right, thanks. Yeah, either way, the latency is, of course, much lower than when injecting to a pod, just because like the amount of instances that you're going to deploy anyway. So now coming to kind of the end of the slide deck here, you have, of course, the advantage with Spring Cloud is that it's totally independent of what it is running on. Now, if you look at all the others, they will only run if they have Kubernetes. In turn, as Josh said, Kubernetes is production. So, of course, a lot of technologies have to adapt to that. Most likely, their things will be running in either one or the other form on a Kubernetes-based environment. And so you can decide for yourself, is that something that I want to exploit then and combine and use? Or would I much rather stick to something that I already have? I don't have a real recommendation there to say this is better, this is worse. I can just like say, yeah, with a lot of people jump on service meshes, in my opinion, without the real need to do so. In the beginning, you had saw there was this meme about like a Kubernetes, like WordPress on Kubernetes, which is already kind of funny enough because I'm not sure if you need that high availability and everything. In addition, with service meshes, it gets even more ridiculous. But I have seen those things. Now, from a standpoint how you can apply it, of course, this is something interesting which I think is going to come and we're going to hear more for in the future. Right now, this also makes a pretty good combination with Spring Cloud Kubernetes because it addresses exactly that points that the other one misses. So the security policies, the encryption between the nodes, and that. So this is probably something I would give a try. Okay. So what am I having here? I have a lot of chaos here, obviously. I have two clusters prepared, and one is running a Kubernetes on Azure, the other one is on Google. That's not really noticeable. One is basically running an Istio service mesh. The other one is running that Cilium, the Cilium eBPF kind of component. So if we, let me just check where I'm currently connected. So yeah, this is the Azure one. So if we look into that real quick, and I'm going to make this a little bigger. So if you look into what I deployed here as a sample application is the Spring Pet Clinic that most of you will know. And if you look into that, you will see that kind of ready 2 of 2. So each of those containers then has an Istio proxy container and the application container. And what I just want to do real quick is look at the. So this is the Spring Pet Clinic right here. I'm going to run kind of a load test using JMeter. So I'm just going to replace that here. And then I'm going to start. So this doesn't do very much from here. And then if I switch to this console, I should be able to get something here. So, I mean, one of the advantages for both service meshes and the eBPF component is that you kind of get instant visibility into your services. So you cannot only modify the traffic, you can all observe it, and then you get your traffic flows pretty neatly visualized without the need of installing any client libraries. So right now I have modified this the Spring Cloud Pet Clinic a little bit, that I have like 2 versions of this vet service. So you can see it here, version 1 and version 2. And of course, this only, the real highlight is the animation, of course. Without that, it's basically useless. And what you can see here is the traffic distribution. So you can see how is the traffic being distributed between the various instances. Now there is no policy applied, so it's basically just being routed by Kubernetes services. Well, actually, there is one applied that I forgot to delete. So this is what it basically would look then. So I have a weight of 90 and 10. And if I look into the graph, I could probably see that now once I get some more load onto that. This is always bad if you're short on time. You should what you should basically be seeing is, I made screenshots just in case, that your traffic is basically balanced in a percentage like this, and then routed to different endpoints. So you could potentially say, I want to scale it up or scale that down or block it completely and so on. This is, of course, more like visual attractive than if I would put some kind of an encryption there, that it's kind of difficult to get visualized. And but sometimes it takes a bit of time until it picks it up. And if there's not enough traffic, then you won't see the distribution. So I'm just going to kick that out, or maybe change something so we will actually see something. Now, on the other side, we have that Hubble UI, which is like the front-end component of Cilium. So there's the Spring Cloud namespace. So right now, it has just detected that those components are there, because there is currently no external traffic. This is something that I'm going to change. The problem, I'm just realizing now, I can't run 2 times the JMeter stuff in parallel. I didn't think about that before, but I'm going to break that one and start a new one. So just need to look up the pet clinic endpoint on the other environment. This is only exposed as an IP. All right, so where is that? And run that one, and shortly we should be able to see things picking up here as well. Well, anyway, this will bring it to an end. I think the most important part is not that this demo now works, so now we can see the API gateway will get some traffic. It has been moved to the side, and then it will be some traffic coming in from the outside world. That's what we just did. And then it gets distributed to the various services and so on. And now I could start applying different policies there. For me, it was just important to give you all an overview of what those various options are. Also, as I said, I did this talk now today for the first time. If you think I missed a certain point in terms of whatever requirements for distributed systems, things how you could address it, please let me know. You can use, of course, this tool also if you liked it or whatever. Feel free to give some feedback there. And, well, first of all, thanks. All right, let's stop here. And yeah, so as we are in Spain, we have to say we have Novatec in Spain, and we have like open positions there. So if all those technologies and the technologies to implement the things in between are of interest for you, feel free to grab one of our guys around here and get in touch. We are looking for more people there. All right, thanks again for listening, and I wish you a nice rest of the day.